Okay, now let's go through a whole hypothesis test. So we have some data here that represents calories per serving in 2 random samples of hot dogs. These tests were conducted separately for beef hot dogs and meat hot dogs, which are a combination of pork, beef, and poultry. We're going to test the claim that the average number of calories in beef hot dogs is different than the average number of calories in meat hot dogs, using the 0.10 level of significance. So step 1, our claim is that the average number of calories in beef hot dogs is different than the average number of calories in meat hot dogs. Since beef hot dogs are mentioned first in the claim, we'll define those as population 1 and meat hot dogs as population 2. How would we know that these are independent samples? There's no mention of paired values. It just says there are 2 random samples that were selected. And the 2 averages are mentioned separately. So our parameter is the difference of the means, mu sub 1 minus mu sub 2. What inequalities should we use? The claim just says that the averages are different. It doesn't say anything about less than or more than, so this is just going to translate to a not equal to. We would first write our alternative hypothesis as mu sub 1 is not equal to mu sub 2, and then subtract the mu sub 2 from each side to get mu sub 1 minus mu sub 2 is not equal to 0. Here's our alternative hypothesis, mu sub 1 minus mu sub 2 is not equal to 0. Our null hypothesis is that mu sub 1 minus mu sub 2 is equal to 0. For step 2, a type 1 error would be supporting the claim that the average number of calories in beef hot dogs is different than in meat hot dogs when the 2 averages are actually the same. The significance level in this problem was given as alpha equals 0.10. For step 3, if we're going to use technology for this, we can use StatCrunch. If we had all of the data in StatCrunch, then we'd be doing t-stats to sample with data. And in this, you want to uncheck the box that says pool variances. So we're doing a hypothesis test. Our number on the other side of our null hypothesis was 0. Our inequality was a not equal to. And here would be our hypothesis test results. So for a confidence interval estimate of mu sub 1 minus mu sub 2, that's our parameter that goes in the middle of our confidence interval. Our lower limit is going to be our point estimate, which is the difference between the 2 sample means, minus our margin of error. Our upper limit is going to be our point estimate plus our margin of error. So let's look at an example of constructing a confidence interval for the difference of 2 means. So we're going to use the same sample data that we used in the hot dog example, and we're going to use that to construct a 90% confidence interval estimate of the difference between the average number of calories in beef hot dogs and the average number of calories in meat hot dogs. So here were our sample statistics. Now what we're trying to estimate is the difference between the mean number of calories in beef hot dogs and the mean number of calories in meat hot dogs. So our point estimate is just the difference between our 2 sample means. So it's the 167.8 minus the 157.4, and that gives us 10.4. So this is estimating how much difference there is between the average calories in the 2 types of hot dogs. We're estimating here that there's about 10.4 calories difference. So to get our confidence interval, we're taking our point estimate, which was the difference between our 2 sample means. So we're taking that 10.4 plus or minus our margin of error, which was 13. So if we subtract the 13, we get a negative 2.6. If we add the 13, we get 23.4. Now the interpretation of this is that we're 90% confident that the difference between the average number of calories in beef hot dogs and the average number of calories in meat hot dogs is between a negative 2.6 and a 23.4. Now here, because we're looking at the difference between our 2 population means, the difference can either be negative, which would mean that the average for the beef hot dogs is actually less than that for the meat hot dogs, or it can be positive, which would mean that the average for the beef hot dogs is greater. because we've got one of each, we've got one negative value and one positive value in our confidence interval. That means that 0 is included in this interval. Our true difference between the two population means could actually be 0, which would mean that the two population means are actually the same. So this implies that there's not a significant difference between the two averages. In other words, the difference between the averages could be anything from negative 2.6 calories, implying that the beef hot dogs have fewer calories, to 23.4 calories, implying that the beef hot dogs have more calories. So this isn't giving us an answer as to which one actually has more and which one actually has less.